Okay, cool. Welcome to our talk, KLM's talk about how we introduce GraphQL in actually our new application that we're building right now. The application that we're building is rolled out in several markets already, but as we add more functionalities to our application, we are planning to roll it out in more markets. We'll dive a bit deeper into that later. What we want to tell you guys today is we're not trying to be GraphQL experts and telling you how to use GraphQL. We're actually telling you how we use it, where we started about, I think it was last summer, it was July of 2016 when we started this project. Where we actually started and where we are right now and the mistakes we made actually, it's also a big important part. We want to prevent you guys from making the same mistakes that we did. So before we continue, we'd like to introduce ourselves. My name is Tom Suijkerbuijk. I'm a front-end engineer at KLM for about almost 2 years now. This is my Twitter account. I'm not really active on Twitter, but you can always DM me and I'll probably try to reply.
And my name is Ugur Korfali. I've been working for KLM for almost 1.5 years as a front-end engineer. Good to see you here.
Cool. So the next slide is actually about introducing Air France-KLM. I'll dive a bit deeper into why it's Air France and KLM, and not just Air France or KLM. But actually, I want to see some hands. Who's heard of KLM before they saw the lineup of this talk?
Woo!
Oh, wow. That's actually pretty sick. And who's ever flown KLM or Air France ever before? You liked it? Can't say no, right? OK. For the ones of you that didn't raise their hands or don't really know us, I got some numbers, some facts and figures to kind of show you guys how big we are or how small, whatever it's your opinion. We almost fly 100 million passengers a year. About 35% of these passengers actually use KLM or airfrance.com to book their ticket and to pay for it, I guess. So we have 36,000 payments on a daily basis. About 110,000 passengers check in using our website on a daily basis. And about 500,000 customers, they look for a flight. And why is this number higher than the actual people that fly us? It's probably the same for you guys. When I'm going on holiday, I usually look for flights for weeks already, and I try to find the cheapest fare, and then I'm looking at a flight, and I didn't decide it yet. And then when you actually want to book it, you end up with a more expensive fare anyways. So that's usually how it goes. So we both work at KLM, as we mentioned, but more specifically, we're working on the BlueWeb Project. The BlueWeb Project will actually replace both KLM and airfrance.com in the near future. We're rolled out now in some markets, I think Arabic Emirates, Greece, Turkey, Ukraine, Saudi Arabia right now. And next week, we'll also go to Indonesia and Serbia, if I'm right.
Yep.
As you can see here, actually, this is our search application as it's going to be in the new website. You can see both Air France and KLM. Why is that? Air France and KLM are two separate airlines, but they merged back in 2004, I think. Well, technically, Air France kind of acquired KLM, but that's details, I guess, right?
Yeah, details.
So what we're building right now in BlueWeb is one Angular application. And when I say Angular, I'm not saying Angular.js. I'm saying Angular latest. So right now, we're on 4.3, I guess.
Yeah.
And
5 is on the way.
This week or next week, they'll launch Angular 5. So we'll migrate to that one as soon as possible. So this is one Angular application, but you can see the resemblance between the two. But one is dark blue and Air France-ish, and one is light blue and KLM. But other than that, it's just the exact same application. So what they did after they merged in 2004, as you can imagine, our airline exists 98 years now, KLM, and the backends are really old. They're not really fun to work with. So what they've been working on is they've been converging the APIs, RESTful APIs, on top of these old airline products, I guess. So that's what we're consuming now as BlueWeb. But we're OK, we wanted new stuff on the front end as well. So Ugur will explain what we have on the front end, actually, and how we work with this.
OK, let's have a look how we are building BlueWeb Project. On client side, we are building our application with Angular and Angular material using TypeScript. As Tom said, we are using Angular the newest, not the Angular.js one. Our styles are written in Sass, and we are using ITCSS as our CSS architecture. Apollo is our GraphQL client, and we are bundling all of them together using Angular CLI. On server side, we are using Node with TypeScript. And our GraphQL servers and application are served on Express and are deployed on different separate Docker containers. And on our server side, we are also leveraging GraphQL tools greatly. As a helper, we are using GraphQL plugin on our IDEs. And if you are people using WebStorm or VS Code, or I don't know if they are having a plugin for Atom, I strongly recommend it. It introspects your schema, it knows your types, so when you are building your queries on your IDE, it helps you with auto-completing your types. One last thing on tooling, we are also planning on using Apollo Optics, or engine, when we are rolled out for bigger markets. As Tom explained, we are currently live on smaller markets, and the data coming from Apollo Optics will be much more precious when we are out for a larger customer group. Okay, this is our architectural schema. Let's have a look a bit. I think it's pretty clear and self-explanatory. So I'm trusting on you people to remember this thing on my upcoming slides, because I'm going to use this one. So please have a look. Okay. No, that won't be fair. Okay, let me just split it down and visualize it for you. Currently, we have 4 main business functionalities implemented. These are search, check-in, checkout, this is our team, yay, and profile. Okay, each of these are developed by a separate group of people, separate teams, and each of these has their own repository and their own release cycles. We are calling these unique business components, UBC for short. And UBC is a module which has a set of flows on a very specific context. For example, our checkout UBC is responsible for collecting your personal information, contact details, let you select your payment method, and then finalize your purchase. Our UBCs are consisting of client and server parts. The client part is not that very complicated. As I already told you, we are using Angular, Angular Material, and Apollo Stack. We are trying to stay close to Angular guides and best practices as much as possible. This helps us to maintain the consistency between our teams. And also, it smoothens the framework upgrade process when it is necessary. On server part, we are using TypeScript, GraphQL Express, GraphQL Server, Apollo Server, and GraphQL tools. However, we have a different setup than actually GraphQL recommends us. We don't have a single big schema. We have a schema for each of our UBCs. Because this is coming from our architecture, it's a requirement, and they want us to separate to deploy our GraphQL servers on different, on separate Docker containers. The reason behind this one is by this way, we're going to scale our GraphQL servers according to their expected load. Because our search GraphQL server expects much more load than our checkout server, because everyone is searching for a flight, but none of them, not many of them returning them to a ticket. So yeah, handling load is really, really important for us. Let's say if our check-in system goes down for more than a couple of hours, then security forces really should act on it and close the roads to the airport to prevent any chaos. So we really wouldn't want to make such a mess there. Okay. Yeah, this slide should come before. Okay, I explained the UBCs. What is a UBC, what part it has, and how we are using these UBCs. We have a shell application. And this shell application has shared functionalities, shared services, and shared configurations. It is also responsible to lazy load the client part of these UBCs when it is requested. It also also maintains the dependencies across the UBCs, the common ones, because if any UBC, if it requires a certain dependency, it should handle it on its own to prevent our main application to get bigger. And as I mentioned, we have these GraphQL servers, which are in communication with our GraphQL APIs. First of all, we thought that we can stitch these GraphQL servers, the separate GraphQL servers, under a middleware, and we can reach it from there as a single big schema, as GraphQL already recommends. But however, this is marked as a single point of failure by our architects, so we needed to remove the implementation. The second question was, what happens if one GraphQL server needs to communicate with multiple APIs? Should we duplicate our types and resolvers in each of our UBC servers? No. We came up with the idea of separation of the types. So we plucked our types out of our GraphQL servers, we put them into a separate repository, we categorized them, we named them after our converged APIs, and we served them as NPM packages. So each of UBC you see there can use these NPM packages as building blocks to form their own schemas. Yeah, basically this is how we proceed with our architectural guidelines. And some of you people might realize that our application, shell application named is Aviato shell. The story behind this one, actually, our architect came to us and said, okay, what will be our internal project name? And we were so hooked up with the Silicon Valley back then, and we jokingly said, what about Aviato? And then he thought a second, he said, okay, Aviato makes sense. It resembles the name aviation, right?
He had no clue.
He had no clue. And here we are. And yes, actually, there is now another Aviato.
Which is us. Okay, cool. So Ugur just explained like what we got from our architects, what we had to work with, kind of. But when we started last year, July, that was not where we started, kind of. So Angular was a given, actually, and back then it was still in beta or in release candidates, I think. And it was kind of a pain to work with in the beginning, and it was new for all of us because it was a new framework. So actually, business gave us some kind of time to like play with it, like to try it, to make it work, and we decided to actually make something useful. We decided to go like to create a small proof of concept with it. So we built basic check-in functionalities. So not selecting a seat, not adding any bags, just give your PNR, your booking code, and your last name, hit check-in, and we'll send you an email with your boarding pass. On the server side back then, we still just had like a simple Node.js middleware where we did some kind of mappings, and like we just mapped the data that we wanted. So it was just like a nice start. But like after a while, we were like, okay, we need some kind of application state. So Redux was a good example because it's a huge user base and a lot of people use it. But I think it was last year, October, we were at Angular Connect in London. And actually, Rob Wormelt from the Angular core team, he like gave a talk about NGRX, which is basically like Redux with ArcGIS. So it looked really good, and we were like, okay, we should roll with this, and we added it to our application, as Ugur just showed. So then actually, this guy next to me, Ugur, he came up to us and he's like, yeah, like we're still like in this proof of concept phase a little bit. And he was like, okay, I saw this new cool thing, GraphQL. Like it sounds really nice. We should like add it to our proof of concept and see if it works. So we're all kind of like, I mean, I was kind of excited, but it's like, okay, like it's the Facebook thing, right? I heard about it, but I didn't really know what it was. So I looked into it a little bit, but some other people were like a little bit more like, like, why is this any good? Like, should we use it? So Ugur came like with the standard, you know, like we all saw these. I don't think I need to go over them, especially not in this crowd. You all know why GraphQL is nice. But a lot of people were also like, aren't we like, we just started with Angular, like aren't we already holding too many things in our stack? And our architect was just happy. This guy actually looks like Ugur if you look very good without glasses. But like, and we were just like barely managing, and it was, but we tried it in a proof of concept, and it actually worked. We made it working, so awesome. Like, let's go. So we had it in. We had GraphQL on our server, and but we still like the vanilla JS type constructors, kind of. So they look like this. They might look familiar to some of you guys. But after a while, like some of our other developers started to complain, like, okay, there's a lot of copy pasting, like there's a lot of things in here that we shouldn't like put in there every time. So actually, we went back to Ugur, like, isn't there like some better thing that we can add, or like, can we do this better? Because people started to complain, and that's not what you want.
Yeah, and there Apollo entered in our radar, actually. On server side, we implemented Apollo, and it immediately relieved us on this type declaration issue. And it also helped us to serve our GraphQL schemas with GraphQL Express. The other good part was it has a middleware for graphical, so it is really easy to implement on your endpoint, and you can just traverse your schema. So yeah, we added Apollo on our server side, and let me demonstrate how it has eased our pain. Okay, we saw already this declaration, and now it becomes this. It's much more readable and requires less typing. And GraphQL Tools takes this string and make it an executable schema so you can pass it to your GraphQL servers. After integrating Apollo on our servers, we implemented it on client also. And as you can easily see, it sits together with NGRX. And then we started to hit some bumps on the road. Okay, what are these bumps? First, the first bump is a multiple footer issue, because NGRX and Apollo are both providing us with stores to put our states in. And now we have two of these. And we said, okay, why not keep both? Just we need to combine them and sync them, because syncing data and cache eviction is the trivial things of software engineering. So yeah, we needed to somehow combine them and sync them. And we dived into the depth of the internet, and we saw that a quite number of people actually having the same issue. And already some people created GitHub repositories to demonstrate how we can solve this issue. And we researched them, and somehow we managed to work them together. But after combining the stores, still we getting some data synchronization issues. And we asked Uri Goldstein to help us out. We sent him a cute little droid, recorded, help us, Uri1, you are our only hope. So he actually did help, and he told us to ditch NGRX at all. He said the Apollo client will be sufficient enough for handling a store. And we finally decided to ditch NGRX. Poof, poof, poof. Yeah, and Rob Wormold actually was with us when I was removing the code from our code base, and he actually agreed somehow. He said, okay, in your case, actually having a second store doesn't make any sense, and removing NGRX will help you to simplify your code base.
Moving his baby, yeah.
Yeah, I did it in front of his eyes. So we did, and thanks to that, we realized that we were using Apollo wrong all along. Okay, for example, we have this multiple currency selection functionality. So you can select your currency, and it will update all the price-related parts of your payment page. Why you want to do that? Because if you want to pay in a different currency than your local currency, your bank might charge you some fees. So selecting your local currency here might minimize your extra costs. So how we did achieve this? First, we used Apollo query to get our order, and then we used a mutation and get the updated order and replaced it entirely. So this is not proper way to do this. How you can do this properly? You can just use Apollo Watch Query to get your order and have an eye on it, and then with your mutation, you will just change the necessary part of this order, and it will be reflected to your UI. And this time was a great moment to refactor our code and expand our understandings on how things should be. We completed our refactor, and then we were like, okay, now we are cool because we can use all the great RxJS operators. We can reactively code our rest of application. And we were smart enough to use do operators of RxJS to apply our side effects. But we realized our side effects triggered twice. And after a long investigation, it took me a while to understand what's happening. We understand that we are also lazy enough to copy-paste everything that we see. The problem was, in our queries, we were requesting the field itself and the fragment also together with it. So this makes Apollo to emit the same data twice. And from the pipeline, the do operator triggered twice. And what would happen, in worst case, actually, a side effect triggered twice, because we have a warning catching mechanism. We are catching warnings out of our order, and we are pushing them into another stream. So if it is triggered twice, then the order pushed on the stream twice. And this gave us a big headache, actually. So this is how we achieved so far, and there's a lot more to improve.
Cool. So yeah, the things that are still on the roadmap, as Ugur just explained, like right now, every UBC, the unique business components that we have, they all have their own Apollo client. But what we actually want to do is we want to move this Apollo client to our Aviato shell and have it in here so that we have one big store. We can use all the cool stuff, like we heard stuff about schema stitching, we heard stuff about, actually I'm not sure if it was mentioned, but multiple clients. We're like just looking right now at what's the right thing to do for us. But this is our idea right now. Like if any of you have any idea about this or like thinks he has a good idea that he wants to tell us, like please do like come to us after our talk. Another big thing that we want to do, I think it's big for everyone, is performance. We're always working on it. Actually with Angular, like I think it comes out of the box now, but it's called AOT. It's something we implemented, I think, a couple months ago now. It's ahead of time compilation. What it basically does is like it compiles your Angular application on build time, and then it just ships it to the browser. So that means two things. We don't have to do it on the fly in your browser, which makes your application faster. And also in the Angular core bundle, they don't ship the compiler like in the bundle to your browser. That's a lot of data saving like for the client. I don't know the exact amount that it changed, but it was a big change. Another thing we want to do quickly is move to Apollo Client 2.0. I think yesterday in James's talk, we already heard like all the cool things that you can do with it. So that's one. It was 5 times faster, I think. That's another good thing. And I think they
half the size.
Yeah, half the size of the bundle. Another thing is progressive web apps that we investigated it a lot. I think it sounds familiar to some of you guys if you travel a lot. It's like you're in your hotel. You go to the airline website because you only fly once a year with that airline, so you don't want to download like their 90 megabytes app. So you go to their website, you check in, you get your boarding pass, nice, close your browser, go to the airport. Then airport Wi-Fi sucks, you don't have Wi-Fi. 4G bundle just expired, and you want your boarding pass. You're like at customs, like shit, and you can't pull it up. And then like if we could serve it to you like from a service worker or something, or Apollo Link offline or whatever, like just like, oh, here's your gate and your boarding pass, go ahead. That would be something really nice and convenient, I think, for our customers. And another thing that we want to implement soon is persistent queries. And in the next slide, I'll try to explain a bit why. As you can see in the next slide, yeah. As you can see here, for example, in India, you would pay like $3.81 for 1 gigabyte of data. And the minimum wage there is 31 cents. So that would mean that you have to work 12 hours and 17 minutes just to buy 1 gigabyte of data. So with AOT, with Apollo Client, with everything that I just mentioned, like if we can reduce the amount of data that we send over the line, like even with kilobytes, like because as KLM, we fly to India, we fly to China, we fly to Indonesia, everywhere, where data can be like a big part of your monthly monthly salary even. So another thing besides saving bandwidth for our customers is whitelisted queries. I think that makes sense, and not showing sensitive data to our client. But these are mentioned before. Don't quote me on these numbers. I got them from the site at the bottom. So, okay, cool. Before we close this, I want to give a special thanks to Uri Goldstein and Rob Wormold. They both visited us in Amsterdam, which was really nice. They always helped us out. They were always there for us. So that was really cool. And you might have seen it. You see it on the back of this one already a little bit. This is the beautiful city of Amsterdam. So I encourage you guys to, when we're rolled out in the US market, to go to klm.com and look for a flight and make sure you make it all the way to the confirmation page, just to have the full experience, right? So you have your booking code. And actually now, like it's only $35 to fly to Amsterdam with free beer, coffee, and food. That's the hourly price for the flight. But it's only 22 hours, so it's not that bad, right? Cool, so make sure to do that. If there's any questions, we'll be around the rest of the day. I already mentioned our Twitter accounts in the first slide. We'll try to respond. And for now, thanks a lot and goodbye from the flight deck.